The water molecules and bubbles provide a good analogy for electrons and holes moving in an energy band. You can consider electrons as water molecules that move down the potential when a voltage is applied. They also tend to stay at the lower part of the energy band. Holes can be visualized as bubbles that flow to the top of an energy band when a voltage is applied. And they tend to stay near the top of the energy band. This analogy, however, has a small deficiency in that electrons and holes carry charges, while water molecules and bubbles are electrically neutral. But it is sufficient to help us to visualize most of the electron and hole actions in a semiconductor. So, you have completed the first module of the course. For now, you should understand the energy band representation of a semiconductor material that governs the motion of the carriers. You should also be able to explain the difference between metals, insulators, and semiconductors. Furthermore, you should be able to distinguish electrons and holes. Finally, you should be able to explain the two driving forces that cause the carriers to move around in a semiconductor. Check yourself to see if you understand these concepts and you're ready for the next module.